Good afternoon, everyone. Very pleased to be in front of a crowded room to present a fascinating project. Et désolé pour tous les francophones, je suis francophone moi-même, mais on a préparé toutes ces slides en anglais et du coup je vais donner la présentation en anglais pour rester cohérent. Et en plus j'ai appris que d'autres personnes pourraient être intéressées de voir la présentation par après, donc ça sera sans doute préférable de le faire en anglais. Donc je re-switch sur l'anglais. So yeah, I'm very pleased to be with you this afternoon just to explain you about our project of bringing clean cooking in school in sub-Saharan Africa using modern biomass. So it's mainly with pellets, but also beyond pellets. So I'll tell a few words about that. So first, I guess better to introduce ourselves. I'm Gilles Gauthier. I'm working in the bioenergy business since 2009. And I recently joined an initiative of the Bioenergy Association, which is a non-profit promoting bioenergy, where I'm contributing or leading a program that is called Sustainable School Cooking Program, which is a program that aims at deploying clean cooking using modern biomass in sub-Saharan Africa. Maybe a bit of context. So I don't know whether you're, let's say, very familiar with the situation of cooking in Africa. And when I say cooking, I'm speaking about cooking for all application, being cooking for a household, but also cooking in institutions like school, hospitals, etc. You have to understand that 80% of the inhabitants in sub-Saharan Africa are still cooking on those very primitive cook stoves. So you have pictures there of primitive cook stoves that are basically 3 stones stoves that are running on firewood or on charcoal, which are creating many issues. One of them obviously being the smoke generation, which is extremely bad for health, leading to loads of premature death. But also there is some environmental issue with that in terms of air emission, PM, so particulate matter, but also CO and of course GHG, greenhouse gases, because it is basically very inefficient use of biomass. And of course there is also a socio-economic problem where a big part of the time of the operator of the cook stove, mainly women, spend a lot of time to collect the fuel, but also to start up the fire. And for the school, it's no different than that. So if you would visit sub-Saharan Africa and visit the school, most of them would be preparing food in this kind of setup. So the 2 pictures on the left, so the one on the left and the one of the middle, are in Uganda. I was personally there. So you see that either they work with a very primitive system, which is the one on the left, again 3-stone cook stove where they put some firewood, or they use what they call advanced cook stove that are the one in the middle. But in both cases, they're using firewood in a very inefficient way. You have, of course, a lot of issues with that. I think the most pressing issue is the smoke. So it is something you have to do once in your life if you want to understand the conditions in which those people are working. It is basically impossible to stand in the kitchen. I've been in the kitchen where you see the picture in the middle, and I could stay there for only 1 or 2 minutes. Your eyes would be watering, you would hold your breath because you don't want to take that in. And actually those people are working with very large spoon, doing a lot of physical effort because they have to, miggle the posho, which is a kind of porridge. So they're doing intense effort while being exposed to a lot of smoke, which is very unhealthy. On top of that, you see that all those systems are basically not closed system, they're basically open system, which means that there is a lot of heat generated in the kitchen. I guess nothing new for you, but in Africa it's already pretty warm up there, and if you add on top of that the extra temperature or the extra heat coming from this, it is nearly unbearable. And there are other aspects that are very problematic too. I mean, the startup of those systems is very long and very complex, but also managing the heat is also very difficult for them, because you have to imagine that they're cooking on 500-liter pot, they're cooking for hundreds of pupils, and they have to adjust the temperature so that they would first boil the water, but after that they have to gently stir it. And with firewood like that, it's very difficult to do it. So that's why we're coming with new solution. And actually, food preparation and distribution in school in sub-Saharan Africa is absolutely essential. You might think, why do we focus on school? We actually focus on school because it's one of the main opportunity for the kids to have properly nutritious food. So not only that they learn at school, but they also properly eat at the school. So it is very important. And on top of that, as you know, the population in Africa is extremely young. So a third of the total population in sub-Saharan Africa is still going to school. So definitely school is an important sector to address, which is the largest user of firewood in the countries we analyzed. And we're not the only ones saying that there is the need for the clean cooking. The United Nations identified that as a critical goal, and you have many options to address clean cooking. You have some fossil-based options that are, of course, not my favorite, biomass, and that's where we would like to play a role as the Sustainable School Cooking Program. So I'm not coming here with an idea, a concept. We've already done that. So we have started, back in 2024, doing the first installation of those clean cooking in Africa. And I would like to report about a few of the great progress we made with those. So started in 2024 in Rwanda, in one school which is made of 1,300 pupils. There, what we did was to upgrade or retrofit, if you like, the cooking stove for them to move away from firewood and better to run on pellets. By the way, the pellets are locally produced there in a sustainable manner because this is sawdust coming from a plantation forest. So the way we do it, we basically take the initial setup, which is the cook stove that you can see on the upright, and we add to that a complete pellet setup made of a hopper, an auger, a hose, and the burner itself, burner that you can see on the top left. These are the burners we would traditionally use, including in Sweden, for converting a heating oil boiler to pellet boiler. So you have a burner that is basically blowing the flame inside, and there we are, instead of blowing the flame to a central heating system, we blow the flame under the cooking pot. And we were also doing some upgrade of the cook stoves. The idea being that the efficiency of those cook stoves is pretty poor. One of the reasons for that is a poor air tightness. The idea was then to improve the air tightness so that the air would have to circulate under the cooking pot for a while, so that you improve the heat exchange with the cooking pot before leaving through the chimney. Otherwise, you just end up, having hot air going through the chimney, which means very poor efficiency. And what we did was to run some tests on the performance of the system before the retrofitting, and then retrofit, and then doing the same test after, so that we can properly assess what are the gains, basically, which is what we did. And here are the results. The results are of 4 different types. First is the cooking conditions. I must say that I'm in the pellet business for years now, since 2009, and this was one of the best projects I've ever run, because you're really bringing a fantastic change to those local people. You have to imagine that those people that are chopping the wood coming from the delivery. So they get delivered some big trunk of wood. They would chop it, they would split it, and they would bring it to the kitchen. Usually they use firewood, unfortunately, that are very humid, which is very bad as well. Then they have to start up the fire. They have to, stir it for a while until it's warm enough, smoky all over the place, or smoke all over the place. Then they put the cooking pot, then they cook. Then there is burnt food at the bottom of the cooking pot, so they have to clean it for 30 minutes, and then they do it again. And they do that for most of those schools 3 times a day, because these are boarding schools. So the pupils, they have their breakfast, their lunch, their dinner there, and they also stay over the weekend. So very intensive use. And when I came there, and when I installed the system, and when we turned it on, it was a revelation for those cooks, because they just have to come with a bag of pellets. They empty the bag of pellets in the hopper, They turn a button just as you would with the natural gas cook stove, and there you go. So they put it on 3, which is the maximum. The water would boil, and then once the water is boiling, they would put it on 1, so it steers gently for them to cook the rice or to do the posho. So the improvement of the cooking conditions is enormous in several aspects. Time, it's much faster. Smoke, it's smoke-free or smokeless. You have actually an output of 60 kilowatt with our burner, and it is absolutely smokeless except for the startup phase, which is for 1 or 2 minutes. It is also done in a closed environment, so that means you don't have this extra radiation you have with the open fire, so you have a lower temperature. And also, as I told you, the comfort to operate it and the regulation of the heat is just a complete revolution to them. So that's for, let's say, the conditions of the cooks. The thing we measured, among other, is the PM, so the particulate matter emission in the kitchen. You wouldn't believe it, but I had with me a PM meter, and the scale of the PM meter is 1,000 microgram per normal cubic meter, which is an extremely hazardous level of PM. And when I would enter the kitchen, you basically max up the measurement of the system. So you see that several times. The orange one is on the firewood. You see that it's reaching the maximum scale of the PM meter. So you wouldn't like to stay in this kitchen for sure. And the green one is basically the pellet system, and you see that for most of the time where you are on the proper load, you have a dramatic increase, dramatic decrease, of the PM emission. So nearly no smoke in the kitchen, no smoke in the chimney. Then one very important element is we don't want this to be, let's say, a donation or a humanitarian project only. What we want is something that is basically, let's say, efficient, and that is also, how would you say that? I'm missing the word now in English, it will come back. But anyway, you have to, what we want to do there is not only to come with a project that is humanitarian, we want to come with something which is cost effective. I'm getting to it now, which is cost effective. So the idea is that it should lead to some savings for the school. And you have 2 types of savings. One is a dramatic decrease of the fuel use, which is leading to saving. The second is a dramatic decrease of labor time, which is also making some saving. So you see on the left and on the right hand, but I'll be quite fast on that. You'll see basically in orange the fuel use on firewood, and on the green end the pellet use. So you see that even if you would take it per unit of energy, so not on weight, which is not the best way to compare it, per unit of energy you have a drop of 46% of fuel use for the same preparation of the same meal. So you're nearly saving half of the fuel on an energy basis, which leads, of course, to cost savings. And here we made some rough calculation about the cost of the energy cost for the meal preparation, and you see that the pellets, which is on the left, is cheaper than the firewood and much cheaper than the LPG and the electricity. Small digression here, just as for Europe, there is a big fashion about electricity. So electricity mobility, or electric mobility, electric cooking is gaining traction in Africa. The only problem is already in Europe, our grid is struggling to handle all that new additional demand for electricity. And when you go there, the electricity grid is everything but stable. So several times a day, you have long electricity cuts. So I don't understand how those politicians believe that the electric cooking will actually solve their their cooking issue. I think it can be a part of the solution with complex system, with PV, battery, etc., to fight against the electricity cut. But I think the first thing is to use properly modern biomass system that allows you to be, that allows you to work without electricity or with very limited amount of electricity. So just to come back to this here, indeed, fuel cost preparation or energy cost per meal is the lowest with the pellets. And here I'm not including the labor cost savings that would even put the pellets in a much better situation. So this first project in Rwanda was very successful. That's all the result I did show you. The cooks were super happy. The school was super happy. The local partner, we have a local pellet producer and also a local installer of those systems, were all super happy. So they decided, with the support of some development agencies, to extend that to 10 schools, and that's what they're doing at the moment. And it goes very well. So you have very similar results. These are the PM emission. You tend to get the exact same pictures for these 10 additional schools. So you have basically nearly no PM emission inside, outside the school. You have the same drop of, even better in some cases, the same drop of fuel use for the different system, up to 60%, 62% based on weight. And here they measured as well the gain in efficiency. Unfortunately, they couldn't do that for all the stoves because the lead engineer had to go back home, and the project was facing a few delays. So that's why you have some orange columns that are basically a bit alone there. But the orange box are the firewood system, the blue box are the pellet system, and you have a gain of efficiency that can be 3 times better. So you move from 25% of efficiency to 75%. And that's due to 2 things. First, the efficiency of the burner that has nothing to do with the firewood system, and also the efficiency, the gain of efficiency of the cook stove. So fantastic results we got there. Of course, nothing is perfectly rosy, so we faced a few issues there, including technical issues, but I think it's just growing pain, because what we're doing there in Africa is basically to bring the knowledge, the European knowledge, the know-how, the technical equipment. We're basically, compiling what we do right for decades in Europe, and just, replicating that in Africa. So I don't believe those problems will last for long. But so there were some downtimes with the system, including because of the quality of the pellets that wasn't the best, so that the pellet intake had some problems. We had a few bugs with the software, but that were solved in the middle. We were also facing some problem when retrofitting the cook stove, because the design of the cook stove made it difficult to retrofit to pellets for some of them. And also we had some paperwork issue. So it wasn't the easiest to ship the burner in some countries in Africa, and including in Rwanda, and the paperwork and the cost related to the custom was higher than anticipated. And now it's going pretty well. We basically caught the eye of the government, which is now very interested in what we did in Rwanda. They've signed now with us a memorandum of understanding to basically install those in 250 schools in Rwanda. That would be absolutely fantastic, but there is a big but in what I just announced. There is no money available. So we have an MOU with the government, but we still have to identify the best way to get that funded. So we're on it at the moment. We're not standing still in the meantime. Just checking on time here. We have other projects, and I will walk you through very quickly some projects. So that's a project in Uganda. I've been there myself, sweating a lot because, my God, that's warm and wet there. So we had a hard time, but we are installing some pellet burner in one school. Very similar setup, very similar procedure than the one I showed you in Rwanda. That's another one from Zambia, where surprisingly they do things differently than in Uganda and Rwanda. What they use basically is those what they call brazier, which looks like a basket full of holes, where they put the charcoal and they put the pot on it. And we're moving away from the large cooking pot of 300, 500 liters. We're speaking here about a small cook stove of 100 liters. They're using their charcoal which is basically radiating all over the place with very poor efficiency and high level of smoke. So we are now working on a project where we will not retrofit, but we will come with small cook stove on a stand that will basically replace those very bad or very primitive system. Now another one, but you have to take this one with a pinch of salt because it's not, let's say, confirmed yet, but I'm so excited with it that I can't prevent myself from showing it to the world. But that is a fantastic program in Kenya called Food for Education, believe it or not, but they are producing 600,000 meals a day for pupils. So it's not a kitchen in a school. They're basically building factories that are decentralized. They would produce food on site and they would ship it and deliver it to the schools. The idea there is that we might be able to retrofit some of their system. The one above is a nice factory they have, but it's running on briquettes, and they have many problems with their briquettes, including for the startup phase, the smoke emission, and again the heat adjustment, where they have to shovel out, the briquettes when they want to steer the pot. So that is complex, and we're in discussion with them. Hopefully, something will be able to promote in the coming months. So that's that for the project to come. But then we wanted as well to increase a bit our portfolio, because what we did so far was to bring the, let's say, advanced pellet technology in Africa. And we thought that maybe for a part of it, this might be an overshoot. There are maybe some other opportunities that are, let's say, more convenient and maybe cheaper than the pellet and pellet burning system. So we are now working on a project to bring wood chips in Africa, or bringing the know-how and the technology to produce wood chips in Africa, which would lead to tremendous saving of wood. Because at the moment in Africa, either they chop the wood for firewood, and usually they use it with very high moisture content, so a lot of waste in very inefficient stove, a lot of waste of energy as well. They also use charcoal, and for the charcoal they're producing that in very primitive manner again, which means that you have a ratio of 1:8. So you need 8 tons of fresh wood to produce 1 ton of charcoal. Charcoal, which is after used in very inefficient way in a terrible burner. So the idea is that we would come with a project of bringing chips, and for the chips you need 1.3 tons of fresh wood to produce 1 ton of dried chips of around 25% moisture content. So that is much more efficient. So we have a project at the moment to produce wood chips over there, and to train the charcoal producer on that, so that they can add wood chips to their charcoal production. I will skip that. The idea is that we would probably go for an electric chipper that would run on a PV and a battery, because at the end of the day, the electricity consumption of a chipper is not that bad. So there is the opportunity to do that with a PV. We also want to improve the efficiency of the system, and we partnered with a leading company of Austria called Ökofen, and they brought a design of enhanced cook stove that could lead to an efficiency up to 80%. So we would be moving from 27%, 25%, 20% to 80%. So it can be up to a 4-fold increase of the efficiency. And also we thought we might have to come with something simpler and cheaper as a solution to bring clean cooking in Africa. So we're currently working with a Vietnamese company, which is quite well developed in Vietnam and in Southeast Asia, where they produce those quite simple burner, yet efficient burner, that are running either on wood chips or even on pellets. And we're currently partnering with them to see whether there is an opportunity to get those installed on top of the, let's say, premium burner we already installed. So that would be it for my presentation. So thank you very much for your attention, and if you have any question, feel free to ask.
Can you hear me? Yes, thank you. Thank you very much for your presentation and for what you have been doing since the beginning on this pellet idea. I don't see the biochar in this picture. So how is biochar connected to the pelletization? We know that pellet is a super efficient way to process, biomass and waste biomass. And so I want to understand a little bit more if you are planning to introduce steel stoves design, or if your retrofitting considers also the opportunity to give out the energy, produce energy, supply energy for cooking, and at the same time produce biochar for the soil amendment. And that's another, strategy and another option. But I'm not sure whether it's technically feasible, or if it's something that must be run in parallel with a different technology. And that's the first question. The second one is on pellet. I missed the piece on how you produce the pellet. I've seen the pelletizers in Rwanda, but from what you produce the pellet, if you can articulate a little bit more on that. Thank you.
Thank you for those two questions. So for the first one, yes, they would be an opportunity to produce and use biochar. But I think, at least for the startup phase, we would try to keep things simple. And I think that what you're bringing here is probably one of the most virtuous way to use the biomass. But my experience with what I saw there at this stage, and I'm not expert there, I just participated in this project, that's it. But what I saw is that we tend to maybe come with our very advanced European culture and try to simply replicate it. And I think we can simplify things a bit. And even with simplified approach, you would have tremendous gains. So I think at the moment we will, try to have them upgrade their pellet production, because surprisingly, every time we look for pellet plants in Africa, we discover more. So there are pellet plants in Africa. The problem for most of them is that they have, not only that they have very little market, but also they have tremendous technical issues. So I think there is the need to support them in, basically properly utilizing or making a proper utilization rate of their units. And then after, when it comes to the use of it with the burners, we also came, with the high tech from Sweden. And on reflection, I think there is also the need to come with this Vietnamese solution that is much more simple. So long story short, yes, your idea is good, but I don't see that as let's say, a kind of objective on the short run. Then when it comes to the pellet production, you have pellet production. We listed 25 pellet production mills so far. And the raw material they're using, at least for the one we're partnering with, is residues, so sawdust from plantation forest wood. So only eucalyptus and pine for the one we're working with. So we don't want, of course, to contribute to any deforestation issue, which is not the case with what we're doing. And the second element in sub-Saharan Africa to me is agri-biomass. There is tremendous volumes of agri-biomass that are just left on the ground. And this can be used. So you think of rice residues, bagasse, so out of sugar production, etc., etc. There are millions of tons available around there. So that would be what we would focus on: sawdust from plantation sustainable wood and agri-biomass. Any other question? I don't know if time allows, but no, it doesn't. So thank you very much again.